Hi guys. Today we will be learning some applications of mathematics, different chapters of maths. I will start a playlist actually. I'll start a series of videos. Today is just an introduction of what we are going to do maybe for the coming 4 to 5 days. Okay, so we all learn second order differential equations. We all learn second order differential equations in college. Okay, and we also learn how to solve second order differential equations. Now there are two types of second order differential equation that we learn. We learn a homogeneous second order differential equation and we learn a non-homogeneous. But many of my friends have actually said that it's of no use learning on differential equations because engineers don't use it. Actually, there is no use in real life applications. So my goal for the coming up videos is to show you how you can actually use second order differential equations. It's not a math chapter, it's just a tool. Okay. Now, along with second order differential equation, whenever you're using it to model different situations, different engineering situations, or may not necessarily be engineering, but any other real life scenarios, you will need to simulate it somewhere. If you don't have the lab equipments, then we will learn how to use Simulink. Okay, so these are the two parts that we'll be looking at: applications of second order differential equations and Simulink. However, Simulink, you guys all need to have MATLAB. Any version of MATLAB from 2011 to 2019 will work, and you can use Simulink. But you need to have the student version. Your university may give you the student version, or you can have the online version. It's free for 30 days. Well, first of all, how we will go around with the videos is we will first revise how we can solve second order differential equations. There are different ways you can solve second order differential equations. You have a table in which in that table, first of all, you'll have different cases if it is non-homogeneous and different cases if it is homogeneous. So there are different ways you can solve different second order differential equations. We will then go on to learn what is the importance of steady state and transient state solutions in maths and in real life applications. All these things we will be focusing on two different applications mainly. One, we have the mechanical system. And the second, we have the electrical system. Okay? The electrical system is very easy. We can just focus on three types of circuits. We have the RLC, RC, and RL circuits. However, the mechanical system is not difficult, it's not complicated, it's just we have a lot of subsystems, we have to learn different kinds of things. In the mechanical system, we will learn mostly about two things. We will learn about springs, and we will discuss pendulums. In springs is the thing that will go for a long time because springs will have different kinds of, for example, damping. You'll have critical damping, under damping, and then you'll have over damped, and then you'll have forced motion. In forced motion, you will be having critically damped forced motion, under damped forced motion, over damped forced motion, and then you will have two special kinds of forced motion, which is resonance and beats. All of these will be learned in springs. In pendulums, we will just learn the motion of pendulum in a two-dimensional space, and these things, actually these concepts we learn in the mechanical system can actually help us build, or I would say more accurately design, a suspension system. We can design different suspension systems. In suspension systems, it can be going for the automobile engineering, you can go for the car suspension, or you can go for the aviation industry, we can design suspension of aircrafts. This is what you can learn from springs and pendulums. From the electrical system, you can see the application can be in circuits and in radios. So we'll have circuits and radios. But let me remind you, these are not the only applications that you can have of second order differential equations. There are many other applications. Now, to study these things, first of all, we need to know if you guys you need to know if you guys are already comfortable with solving basic differential equation as it is, because I will not be going in detail. For example, you need to know how to solve this differential equation. So for example, 6x double prime plus 7x prime plus 8x is equal to 9. You need to know how to solve this basic differential equation, or it can be is equal to 0, so to become homogeneous. You need to know how to be able to solve these kind of differential equations. If you're comfortable with solving differential equation, that will be very helpful for you to actually go through these topics. For example, we will learn in springs. Let's take what we will learn in springs. In springs, we will take Hooke's law. In spring, we will learn about Hooke's law, how to apply Hooke's law. We will learn about Newton's laws. Okay. Now, the beautiful thing about all these topics are that none of these things we will have a differential equation given to us. It will be a statement. Like for example, we will have a spring. Let's say we will have a spring of 5 kilograms weight attached to it. Okay, and we will just have to analyze the motion of the spring. So what to do, how do we analyze the motion of the spring, the vibrations of the spring caused by the spring, or anything that we can do by changing the weight of the mass, is that affecting the motion of the spring? So we will only have this physical situation. We will not have any differential equation. By using Hooke's law and Newton's laws, we can actually manage to get a differential equation for this, solve the equation, and then get our answer. For an electrical system, we will have our circuits. We will have an RC or RLC circuit, and then we can obviously go and design a differential equation based on Faraday's laws, based on different electrical laws, and actually we can design a differential equation. Okay, or we can use Kirchhoff's laws. So these are the many laws that we can use to design circuits as differential equation models, second order most importantly, and we can go ahead. And at the end, when we learn all these things, we can take our knowledge to simulate and see how we can arrange it in block diagrams, because it is very important to arrange the whole thing in a block diagram, so that, for example, you left your work and then you want another engineer to view it, then you actually need to present it in a block diagram, and then which can automatically give you a graph of the motion, either a mechanical motion or the charge, the changing of the charge in an electrical system. Both these things, if you do in a Simulink, it will show you an exact graph, and then we can design a Simulink model. A Simulink model can actually go ahead and further, you can design an aircraft control system. It can help you design many different kind of control systems, and having the knowledge of differential equations or mathematical models is very important. Well guys, thank you for watching the video. Please watch my further videos to be coming out. I'll be starting with mechanical systems from tomorrow or the day after tomorrow, and we'll go ahead and cover everything, hopefully. So thank you for watching, and please subscribe to my channel.